Okay, today we're going to work on lesson 712, Rules, Tables, and Graphs, Part 2. So our objectives today are we want to be able to use rules, tables, and graphs to compare real-world relationships and solve problems. Success criteria, we want to be able to accurately use rules, tables, and graphs to compare real-world relationships to solve problems. So we're going to look at some of those things today. But to get warmed up here, we have some decimal multiplication. And if you remember the way we've done things in the past, we could do a couple things here. First, if we make an estimate, that's always helpful. When I look here, I see about 50 and 17. I could say it's about 20, and that makes it something easy to multiply. And I know 5 times 2 is 10, plus 2 more zeros gives me 1,000. So I know my answer should be somewhere in the thousands. That'll help me when I go to place my decimal. And then I'm going to actually just multiply and pretend the decimal doesn't exist. And so if we go through, do our multiplication here, we know 3 times 1 is 21. 3 times 4 is 12, plus 2 is 14. 3 times 5 is 15, I get 16. And you could use the area model way, you don't have to do it this way. But I'm done with the ones, so now I'm going to go to the tenths. I know 7 times 7 is 49. Carry my 4. 7 times 4 is 28, plus 2 makes 32. And I know 7 times 5 is 35, plus 3 is 38. Now I'm moving on to the hundreds place. I'm going to add 2 zeros for my placeholder down here. And I know 1 times 7 is 7, 1 times 4 is 4, and then 5 times 1 is 5. So when I add those up, if I've done it correctly, we'll see what we get here. Okay, so I should have 7 plus 2 is 9. 9 plus 6 is 15, 16. 2 plus 8 is 10, 14. Carry my 1. And I should get this. So I should have 9, 4, 6, 3, 1. And when I look at my estimate of 1,000 there, I can see that my answer should probably be 946 and 31 hundredths. So my decimal would go there. Another way I can check where to put my decimal in the end is see how many digits are to the right of the decimal. In that case, I can see there are 2. So if you need to, go ahead and pause the video and study that. Otherwise, you can look here. You have another problem, 608 and 2/10 times multiplied by 1 and 2/10. So I'm just going to do the estimate with you, and then I'll let you do the rest of that on your own. So I could say 600, because I like to, when I estimate, use 2s, 5s, 10s, hundreds if possible to get as many zeros as you can. And then let's see, this is close to 1. So I know my answer should be around 600 when I do my multiplication. So go ahead and pause the video and complete the multiplication for that one. Okay, and then the next one here, before we move on to our math journal, let's just look at this for an estimate. Again, if you're home, you want to do the actually solve this one. So when I look here for an estimate, I'm just going to say 10. It's pretty close. And I notice here it's less than 1. So I'm going to actually just multiply it by 0.5 or half. And I know that half of 10 is simply 5. So I know somewhere my answer should be around 5 for that product. So again, pause the video, work that out, and see where to place your decimal. Okay, now if you go ahead and turn to page 270 in your math journal, and you're going to see the math message there. So I want you to take a few moments, we'll read through this together, and then I want you to take a few moments, pause the video, and try to see what you can come up with when we do the rule. So it says Kayla earns $20 per hour. Write a rule that describes how much Kayla earns. Well, I know she earns $20 per hour, and I can see down here her hours worked is X. So I'm just going to say the X multiplied, and actually let's not use X though because of multiplication might be a little confusing. Let's go ahead and use H for hour. So I'm going to say hours multiplied by 20. Or I could write it as H multiplied by 20. And H stands for hours. So I want you to take a moment, pause the video, and I want you to fill in her earnings based on what the rule of $20 per hour. Okay, hopefully you've had a chance to do the earnings and write the order pair. So let's go through here together. The rule is multiply by 20, so I know 1 times 20 is 20. So that's $20. If she works 2 hours, she makes $40. If she works 3 hours, she makes $60. Now, we're going to be actually writing these on a graph or plotting these, so we need to make sure we write them as an order pair. So the X always goes first, and then the Y. So our next one there, we know she works 2 hours, she's going to make $40. And when she works 3 hours, she's going to make $60. And we could continue that pattern on to see that. So make sure that you have that, that your numbers are in agreement with mine. Okay. Now, let's look at problems 1 and 2 here. So it says use the rule to complete each table. Write the order pairs to represent the data. Then create a line graph and answer the question. So let's look at this here. We see Andy earns $8 per hour, so he's not making near as much as she was. But $8 per hour, number of hours worked multiplied by 8 equals his earnings. So I want you to go ahead and do the first one here. So let's look together. So we know hours worked is 1, and he makes $8 net. But let's look down here. I know when I have the out but not the in, when I get the y but not the x, I do the opposite of the rule. So instead of multiplying by 8, I'm going to take this 40 and divide by 8. And I know 40 divided by 8 is 5. So I want you to pause the video and go ahead and fill in the earnings, and then come back and we'll do the order pairs, and then we will plot our points on the graph. Okay, so hopefully you paused the video, took a moment to do that. So let's go ahead and check your answers against mine here really quick. So we see that 2 times 8 is 16. 3 times 8 is 24. 7 times 8 is 56. So we're going to write our order pairs. So we know when he works 1 hour, he makes $8. When he works 2 hours, he makes $16. When he works 3 hours, he makes $24. When he works 5 hours, he makes $40. When he works 7 hours, he makes $56. And this is something actually will be helpful when you eventually get a job and you find out your hourly wage. You can figure out how much your paycheck will be before taxes. Okay, so now we want to plot the order pairs here. So I have number, the first one is 1 hour and then $8. So if you look here on the y-axis, this is our earnings and this is our hours worked. And the other thing I want to notice is the squares. I need to see how many go from 0 to 10. 1, 2, 3, 4, 5. So I see, if I count by 2s, it should give me the 10. 2, 4, 6, 8, 10. So I know that each one goes by 2. So that will be helpful when I'm counting up if I don't have exactly 10. And the first one we know he works 1 hour. So I'm going to go over to the 1, and I'm going to count up by 2, so I get to 8. 2, 4, 6, 8. And I'm going to put my point. And then what I like to do just to kind of keep track is I don't cross these out, but I do put a check mark. Now, when he works 2 hours, he makes $16. Okay, so I go to the 2 and I can count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. And I plot my point. And I'll go up and do the same thing. So we'll do one more together, and then I'll have you pause the video and fill in the rest. Okay, now we're at 3 hours, and he's going to make $24. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24. And again, you may not have to count all the way by 2s to 24. You could look at the 20 and count up there to see as well. But on my board, it's a little bit harder for me to see. And I kind of missed the spot right there, so let me fix that. So on my board, it's a little bit harder for me to see. In your book, I think the lines are a little bit easier. They don't blend together as much. And then so I would go up here and then check that off. So I want you to pause the video, and I want you to go ahead and plot the point for 5 hours at making $40, and then working 7 hours and making $56. When you're done, I want you to use a straight edge and connect the points. So pause the video now and complete that. Okay, hopefully you've had a chance to do that. Plot those. So let's look together. We see the 4. I didn't have any data points, so I'm going to go straight to the 5. I'm going to go over to 40. and go all the way over to the 5, and that's okay because our line will still go through the 4-hour mark, and we can still use the rule if we need to find out how much money he makes working 4 hours. And then the next one was 7 hours and making $56. So I go over to 50, the 50 line, and I'm just going to count up 52, 53, or sorry, 50, 52, 54, 56 right here. And again, you want to use a straight edge. I will do the best I can on here to make a line for you. And we actually here would want to use a arrow because it could keep going. He could work more hours. Now you may say, oh, well, who's going to work more than 8 hours or 7 hours in a day? But this could be his whole paycheck. This could be two work weeks where he worked 80 hours or more. So that's why you would want to keep the arrow going the other direction there, because he could work more hours. He can't work less than 0 hours. If you don't work 0 hours, then you haven't worked at all. Now, let's look at D. It says plot a point to show Annie's earnings worth 5.5 hours. So again, I look at between the 5 and 6, and I got to count to see how many blocks there are. 1, 2, 3, 4, 5. So each one counts as 1/5. And so on this one, we just want to look at the halfway mark. So if I go over 2, that's not quite enough. It's in between right here. And if I have a pencil, I can go all the way up until I intersect with this line. And I could follow it over. And you would want to erase this. But I can see that he would be working 42 hours. Another thing we could do to check just to see if our line is accurate is I could multiply. So I'm going to convert this to an improper fraction. And I could say 11 halves. I get 88 over 2, which gives me 44, which I can actually see I needed to go up one more there. So my line was a little bit off of my points. Again, it'll be easier to see in your book, but you actually should have a point right in here, okay, at the 44 mark. So he would earn about $44 if he worked 5.5 hours. Okay, so you can see there how we could use the line graph to help us find. Now, we're going to go ahead and look at number 2. This one is way more involved with the data, so we're going to read through here and see what we come up with. It says Eli's 10 years old and can run about 5 yards in 1 second. So I don't necessarily need to know his age, so I'm just going to go ahead and put an X through that. But I do need to know that he can run 5 yards in 1 second. His sister Lupita is 7 years old, and she can run about 4 yards in 1 second. So I just need to know all about his speed, because when I look over here, it's about time and distance, time, distance. Doesn't ask about their age. Eli and Lupita have a 60-yard race. Because Lupita is younger, Eli gives her a 10-yard head start. Complete the table showing the distance Eli and Lupita are at the starting line after 1 second, 3 seconds, and so on. Use the tables to complete problem 2. Okay, so we know gave a 6-yard race. Eli gave her a 10-yard head start. So that means that Lupita got to start before Eli did. So we just need to kind of look at the rule here. So I can see 0 to 0 doesn't help me. 1 to something, but up here it says that in 1 second, Eli can run 5 yards. So I know it's 1 times 5. And then you can go through and fill in the rest of that chart. When I look over here at Lupita, here it says that Lupita can run 4 yards in 1 second. Okay, she already has a 10-second head start, so we have to keep that in mind as we go. So she already has 10 yards ahead. Then she runs 4 yards per second, so I got to add 4 to that. And then I'm just going to go all the way down, and each time I'm just adding 4 more yards because she got that head start. So I would fill that in all the way down. With pattern there, okay, so you're just adding 4 yards each time. Let's see, does that? And let's kind of look at that again. Okay, so she starts at 0. So she gets a 10. She's got 10 yards already ahead of her, and then she runs 4 yards per second. So yep, then I would add the 14, and then I go to 18, and then I go to 22. Then at 4 seconds, she runs 26. Then she runs 30. Then she runs 34, and then you can fill in the rest there. Okay, so you can see here, because she got a 10-second head start, that already gave her 10 seconds without even starting. And then she just runs 4 yards per second. So you just keep adding 4 to that. Over here it says Eli can run 5 yards in 1 second. So you just keep adding 5 all the way down. Then you're going to use the information from here. You're going to tell me who wins the race. So you're going to go all the way to the very end and tell me who wins once they get to 12. Who has ran farther? How long does it take the winner to finish? And the one thing to keep in mind is that the race is 60 yards. So we want to know who reaches 60 yards first. And then who is in the lead the most during the race. And then Eli's rule and Lapita's rule. So go ahead and take a moment, pause the video. I want you to fill in the rest of this chart and see if you can answer those questions. Okay, hopefully you've had a chance to fill those in, so let's do this together and you can check your math against mine. I know I'm going up by 5 each time. We're just multiplying by 5. So we can fill these in. And then over here I can see Lapita is just adding 4 every time, because she can run 4 yards in 1 second. And I made a mistake there, so be very careful. If you make a mistake, it'll mess up the rest of your numbers. Okay, so when I look at this data, now it asks who wins the race. So hopefully you've already figured this out. But if we look, we know it's a 60-yard race. Who reaches 60 yards first? I can see that, looking back here, Eli reaches 60 yards. Lapita would still have to run another half second to get that. So who wins the race? It would be Eli. So again, we're just interpreting data. How long does it take the winner to finish? Okay, so to cross at the 60-yard line, it would be Eli, and it took him the time of 12 seconds. Who was in the lead during most of the race? So that's interesting. We got to kind of look and compare here. So when I look here, Lapita's in the lead. She's 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 in the lead here. Here they're tied, and then Eli took over. And if we go all the way back up to the top, remember Lapita started out ahead. So Lapita led most of the race, and then Eli probably took off at the end, or sped up to beat her. So hopefully you have those same answers, and if not, then make sure you check that. Now, Eli's rules. What do we do for Eli? If we go back and look, we start at 0, 0, so that's not really a good rule. But we know he could go 1 second equals 5 yards, and so we were able to multiply by 5. So Eli's rule is seconds, or second, times 5. And then for Lapita, we know we count it by 4. We look past the starting point of 10 here. We can see we just added 4 each time. So we could say Lapita, 10 seconds plus 4. So all we did was each one, we looked at it as 10 seconds, and then we added 4 more each time to that. So you can see there, we, again, just took the seconds plus 10 plus 4. Now, if you were to graph this, you would see, or sorry, this is for going back to Carla and Andy for some money here. So here's some questions that you could ask yourself as well and look at. So how many hours did it take Andy to earn $40 for Carla? And then how much for Carla? So compare those two. If they both start work at 8 a.m., by what time will Andy earn $40? And then what about Carla? And how many more hours does Carla work than Andy? Okay, so you would just want to do this work on your marker board or paper at home. Take a picture of that and then just send it to your teacher. All right, that is the end of this lesson.